Hello and welcome to our fifth episode in our series covering the key principles in Steve McConnell's new book, More Effective Agile. Welcome back, Steve.
Thanks for having me.
So today we're going to cover an additional three topics, three principles under the heading of more effective Agile projects, whether they're small or large. And so let's go right into it and touch on the first key principle under this heading, which is manage technical debt.
Okay.
So, this is a loaded topic. I feel like we could devote an entire podcast to this. So let's maybe start with a definition for those who are not really familiar with the phrase. I mean, everybody has it. It's like GERD, right?
Or sleep apnea, maybe.
It produces GERD, I'm sure,
yeah.
right?
Right. I do think it's important to define what we mean by technical debt, and a lot of people use the term technical debt interchangeably with low quality or defects, and I think that's not super useful. All it really does is dress up the term defects to mean something else. When I refer to technical debt, what I mean is taking an approach that is expedient in the short term, but that results in increased cost of doing the same work later than it would cost to do now. There's both a forward-looking aspect to technical debt and a backward-looking aspect to technical debt. On a backward-looking basis, I would agree actually that there's not a lot of difference between technical debt and just low quality or defects. But then I think you don't gain anything by referring to the concept as technical debt versus defects. On a forward-looking basis, I do think there's a difference, and that's where, when we're trying to make a decision about which of two or more technical options to choose, if we're talking about one being quick and expedient, and but maybe creating more work in the long run, that would be the technical debt option, and then that's typically contrasted with some typically more time-consuming approach that does not require additional work or incur work on an ongoing basis because of it not being complete or high quality.
Right. So you talk about 5 categorizations of it in the book, between intentional and unintentional. So maybe you can kind of talk a little bit about those.
Yeah. So, I think that, again, I think talking about unintentional technical debt is essentially just talking about, there are two kinds of unintentional debt. There's unintentional debt that is just due to carelessness or sloppiness,
right?
And it's like, we don't have time to do design, and so then that comes back to bite you when the fact that you didn't even think about the design doesn't turn out very well. There's also, I put in the category of careless mistakes. The other category of unintentional technical debt is just due to the fact that what we do is complex and we're never going to do it perfectly. We can have the best of intentions, make a good faith effort to do the work well, and we're still going to get it wrong sometimes. And we make our best judgment about a design approach, and then as we work our way into the details, we discover that design approach actually didn't contemplate everything it needed to, and so then we end up with some extra work. So that's really unintentional technical debt. Intentional technical debt mostly, I think, breaks down into bigger chunk items where we can identify the individual debt items, and smaller chunk items where they're so numerous that we can't even identify them. So in that small category would be, the example I typically use is, guys, we don't have time to dot every I and cross every T, just get it done, which is kind of a license to take shortcuts. I think that kind of technical debt is always inadvisable because we have no way of going back and fixing all that stuff. I think beyond the fact that we have a difficulty fixing it, it's extremely questionable whether that approach actually accomplishes its desired objectives. The statement of, guys, we don't have time to get to dot every I and cross every T, just get the work done, implies that if we don't dot every I and cross every T, somehow that will save time. In practice, I think it doesn't save time. I think it wastes time because what we end up doing is fighting poor quality code base instead of just working in a more methodical way against a backdrop of a high quality code base. So I think that form of technical debt is very much death by 1,000 cuts.
And that can be a discipline issue as well. Like if it happens on a rare occurrence, then maybe you accept it. But if you do it a lot more, the accumulation is like snow in that case, right? Where it just layers upon layers of those decisions.
I think that's right. And I think sometimes it's a discipline issue. Sometimes it's a competence issue. Sometimes it's an issue of technical staff thinking that their management wants them to do something that their management actually doesn't want them to do. I like what Larry Constantine said many years ago when he said, "You don't need permission to do your job well." And I think that bears on this discussion of, you'll hear technical staff complain that their managers want them to work in a way that to them seems irrational. I have rarely found that actually to be true. I've certainly seen many cases where technical staff believe that, but when you actually talk to the managers, their managers will say, well, of course we don't want them working that way if it takes longer. We want them working in the way that produces good quality, and we really just want them working efficiently. We don't want them working, in some sense, stupidly.
Sure.
So that's the death by a thousand cuts version of intentional technical debt. The other category is larger grain items where we're making some specific design decision, or we're deciding to do some sort of a workaround temporarily and go back later and fill in the workaround. These larger grain items are big enough that we could actually put them into a product backlog, or we could put them into a defect tracking list. To me, the litmus test for whether we're talking about large grain or small grain is the trackability aspect. Is if we can track it, and if we actually do track it, then it's large grain, and then we set ourselves up to actually go back at some later time and correct the technical debt. But if the thing is too small to be worth tracking, then in my mind it's too small to produce a gain that would be worth degrading quality for, and so we shouldn't do it in the first place.
Right. So even things like conscious platform support, for example, would fall in that category. Like if you're building across a number of different platforms in mobile or something else, you could say, I know the majority of users are on this platform. We're going to target those first, and then we make some conscious decisions to get support for that platform quickly, and then maybe follow up with support for other platforms that are not as popular, and maybe you make a decision that way.
Yeah, possibly. I do think that sometimes people will use the phrase technical debt to refer to work that I would just refer to as deferred work.
Right.
If there's no notion that the work costs more to do later than it costs to do now, then it's not technical debt, it's just deferred work. And, we can't do everything first. And so the fact that we choose to do one thing first rather than another thing doesn't necessarily imply that there's any technical debt being created.
Right.
In the multi-platform support example, really depends on whether, if we choose to support one platform first versus having a multi-platform strategy, is the incremental cost of adding that second platform significantly higher because we implemented only one platform in the first place, or would a multi-platform strategy have made it significantly cheaper to do the second platform?
Right.
If the second is the case, then you could argue that there's some technical debt being accumulated there. In the book, I also differentiate between long-term and short-term technical debt. We've talked about the distinction between intentional and unintentional, and the distinction between large grain and small grain. I think those are both useful distinctions. Even though I historically have distinguished between long-term and short-term technical debt, I actually don't know that that's as useful a distinction as these others. The platform one might actually be a reasonable example of a long-term technical debt. If we don't have a need to go to that second platform for another, 2 or 3 years, then that could be construed to be a longer-term debt. But
Right.
I'm not sure how useful it really is to differentiate between long and short term.
Makes sense. And then there's one other one that I think a lot of people who have been in business for a long time or who have had supported platforms internally, and that's the notion of legacy technical debt, where people just have, by definition of being in existence for a long time and having built on something for a long time, you have this legacy code base, and there's things nagging at you in that code base as you continue to build architecture on top of that. So that's another one that comes up quite a bit in conversation with our customers.
Yeah, if I want to be picky about terminology, I'm not sure how much of that would qualify as technical debt in terms of costing more to do later than it does to do now. But I do think it's a really interesting quality issue when you look at long-lived legacy code bases. And one of the dynamics with software in general is if your software is successful, it will last a long time.
Right.
And it will get extended. If you're not successful, that's really the only case where you throw it away, unless you're doing prototyping or Spike or something. But if you're successful, your software probably lasts longer than you ever imagined, and will get extended in ways that you never imagined. And as that happens, there are a couple things that happen. One is, as years go by, our notion of what constitutes good coding style and good coding practice actually changes. So if you wrote something 10 years ago that was considered really good quality at the time, from today's vantage point, it might not actually look that good. The style is a little bit different, and so you get this notion of style drift that occurs over time. Likewise, we want to try to extend code as far as possible and not have to just throw it out and start over. But as we do that, typically we're extending the code beyond the design envelope that it was intended to serve. And you get to a zone where you're kind of in the gray area of, should we actually be rewriting this, or can we just extend it a little bit further? And I remember when I was at Microsoft working on Windows 3.1, at the time I thought the code base did not look that good. And we got a very good quality product out. And then when Windows 95 came out, which was based on the same code base, I was actually pretty impressed that they were able to extend the code base that far, because it was a significant extension. And given the code base they were starting with, I did not think they'd be able to extend it that far. And then they actually extended it even further into Windows ME, which was the same code base. And at that point, I was really, really pretty shocked that that code base had lasted as long as it had. So I think all that is just illustrative of the fact that code lives a lot longer than you think it will. And
Sure.
One of the absolutely classic mistakes in terms of accumulating technical debt is taking design and coding shortcuts based on the expectation that the code base is going to be sunsetted. We often see organizations say, all right, this is the last release. We're going to do a re-architecture after this release.
Just one more.
Yes. And then, 2 years later, you're still actually working on the same code base,
Right.
and the business hasn't actually sunsetted that earlier code base.
So to tie this back into the Agile practices and Agile projects discussion, do Agile practices actually help you reduce technical debt in a more efficient manner than waterfall, or is it just something that's maybe in the concept of being able to chip away at it, you can fold it into a backlog in a more expeditious way?
I think this falls into the category of power tools can be used either for good or evil, and I think Agile practices can either help or hurt in this context, depending on how they're employed. I think the way that they can hurt is that if you maintain an overly code-focused approach, you never think about design, you can definitely code yourself into some corners in terms of how you could potentially evolve the system. On the other hand, if you put a little bit of attention into design thinking as you go, then the iterative nature or incremental nature of Agile development can really help keep a lid on technical debt, because you can work on it incrementally. And one of the failure modes that we see pretty often is when companies take on so-called re-architecture projects. It's pretty common for companies to spend, or project teams to spend 3 months or 6 months on some vaguely defined re-architecture project. And those almost always end disastrously, where we've seen cases where at the end of 6 months of effort, they have to roll back to the last known good state in the code, which was 6 months earlier.
Yikes.
We've seen cases where they have difficulty rolling back to the last known good state in the code, and that may be even more earlier than when they started the re-architecture effort. So I think the incremental focus of Agile is really helpful, where and especially and importantly, if that's combined with the focus on maintaining a releasable level of quality at all times, then as we incrementally reduce debt but maintain releasable quality throughout, that can be a really powerful way to reduce technical debt.
Well, that's great points. And one of the things I thought about when you were talking there was this idea that sometimes business folks who are involved in an active decision-making process for features in a new release or for features downstream, the business people might not be aware of the true cost of of taking on certain kinds of technical debt, or actually the true cost of eliminating it. And so maybe by showing them in a small that here are some trade-offs, or we need to reduce this or retire this moving forward, they can accept it more easily because it's in small pieces, as opposed to being overwhelmed by, we have to take 6 months off the development cycle and go fix this.
Yeah. Yeah, I think that some people have really tried to formalize the concept of technical debt and measure it and that kind of thing. And I think, that's fine. Some people can do that. To me, the most useful part of technical debt is literally the metaphor of technical debt. And I think it's an extremely useful communication tool for communicating with the business. I mean, technical debt, the way I think about it anyway, of trading off some kind of lower cost now for higher costs later, is a concept that business people can understand. The metaphor of, we're going to take on debt now because we need to shorten time to market or shorten time to the next release in exchange for an interest payment where we're going to have to pay more later to do this work well. It allows the business people to make a business decision about, is the amount of time we're going to save really worth it compared to the additional costs we're going to incur later. And I think technical debt in general is a pretty interesting intersection of business considerations and technical considerations. It's not an area where the technical staff is just making decisions on its own.
Right.
It's an area where it properly does involve the business staff to say, well, what's it worth to shorten the development cycle by this amount? And overall, is it worth it? And so giving the business people a way to engage with that and some kind of mental model for how to think about it ends up being a really useful thing and helps to engage them in the decision-making process that they properly should be engaged in.
Right.
So that's really the thing that to me is the most valuable about the technical debt metaphor, is the ability to engage a business staff in a meaningful way for this category of decisions that really require both technical and business decision-making at the same time.
Well said. And I think in an Agile context, they get more looks at it, right?
Right.
In terms of
right. I mean, if in an iterative environment, you've got your product owner and your other stakeholders who are normally taking a look at what you're doing at least every couple of weeks. Product owners more frequently than that, but yeah, we have frequent touch points for that kind of decision making with an incremental or iterative approach.
Cool. Well, I think we're going to stop it there on that particular principle. I think that's a good segue. We did talk a little bit about architecture related issues with regards to technical debt and how do people reduce some of those things. So kind of leads us to the second key we want to talk about today, which is supporting large Agile projects through architecture. Mm-hmm. So let's parse that. In general, Agile or not, history shows that software organizations have struggled with large projects, right?
Yes, absolutely.
In general. That's just been between Brooks and Conway and a lot of the writings about those folks over time,
yeah.
Right? So the idea with Agile is, again, about partitioning work down into manageable chunks and increasing the chances of more successful work, right? More successful size work?
Yeah, I think so. For people who aren't familiar with the idea of Conway's Law says that the structure of a system will reflect the structure of the organization that built it. And there are a number of corollaries. If you have 10 people working on a system, you can guarantee that you'll have at least 10 modules or classes or sections of code. If you have your team spread across multiple geographic sites, sooner or later the system is going to reflect that as well. We had one client who was in a hardware manufacturing context, and he said, if you take the box off our device and look at the chip layout on the board, it basically matches the geographic layout of the teams. And
interesting. Wow.
That's a pretty literal example of Conway's Law, but the idea that the partitioning of the technical work matches to some degree the organization, or you could call it partitioning of the human staff, is a pretty common phenomenon. And from an architecture point of view, it cuts both ways. We can set up the architecture of the system so that it works well considering the human organization of the system, or we can take it the other direction and say we can set up the human organization of the system so that it is congruent with the architecture of the system. Where we run into problems is where we have incongruence between the architecture design, or the partitioning in the architecture and the partitioning in the human system. And with Agile, we're really trying to get to have the work done in small teams, and ideally with minimal to no need for coordination across those small teams, even on a large system. And so in our approach to architecture, we should be trying to architect the system in a way that supports minimal to no need for coordination across the different elements of the architecture. And certainly the current focus on microservices and so on is consistent with that overall objective.
So loose coupling, modularity, things of that nature. Right?
Yeah, it kind of takes us back to those classic ideas of high cohesion and loose coupling. I mean, those have been very durable concepts in software. The looser we can make the coupling in the software design, and that implies looser connections and communication paths between the different teams. And as we increase communication paths between the teams, if we have no communication paths between the teams, then we effectively can have a bunch of small teams. As we increase the number of communication paths among the teams, those small teams start to look more and more like a big team, and then we get all those large project issues.
Right. So let's get a little geekier here. Let's talk about monolithic versus loosely federated databases. Explain that, Lucy.
Well, this really is the same kind of issue where if we can have more of a federated approach to our database, then we can have a more federated approach in the code that accesses the database, and then we can have a more federated approach in how we compose the teams. So, the database is really, I don't think it's that distinctive an issue as an example of Conway's law from any other, from software design in general.
Right. So you also mentioned a couple other things. One is using queues in the book, and that's another geeky rabbit hole if you want to go down that. But just talk a little bit about that, maybe in terms of the idea of scheduling.
Yeah, I think the idea of how do we pull the pieces apart in such a way that they really are loosely connected. If we're really strict about the execution sequence of things, bearing in mind that when we talk about execution sequence, we're talking often about milliseconds or microseconds.
Right,
we're not talking about hours.
Right.
There are instances where if we can set up queues, we can execute loosely, asynchronously, in a way that probably doesn't make any difference in terms of the user experience, but that in terms of allocating responsibilities to different components sets us up to have more independence between the different pieces of the system. So again, I think that's just a way, one possible consideration in how we separate the pieces and therefore separate the teams.
So your principal consultant here at Construx, Steve Taki, talks a lot in his design classes about design by contract.
Right.
It's another thing you mentioned in the book, and we teach that in our courses all the time. You want to kind of elaborate on that a little bit as well?
Yeah, the basic idea behind design by contract is that each routine is considered to have what are called preconditions and postconditions. And the preconditions are the assumptions that the routine makes about what will be true at the time the routine begins executing. So it can be input parameters within a certain numeric range, or a file has already been opened, or some sort of data link has already been established, or it has not been, or you have a certain amount of capacity available for storage, or it can be almost anything. But the idea is that you formally define what the assumptions are that the routine is based on. And those are the preconditions. And the postconditions are you could think of it as the promises that the routine makes to its caller about what will be true by the time the routine is done executing.
Finishes, correct.
It's exactly the same kind of stuff that goes into the preconditions, but of course the details will be different. And when you use design by contract, when you use it with some discipline, you get a much clearer set of expectations about what assumptions the routine is actually based on.
So it helps limit dependencies in some respects, or unknown or unforeseen dependencies, maybe assumptions that people make that are not valid.
Well, I think it depends. So this ends up just being a question of how you implement it in code.
Right.
The language that's most strongly associated with design by contract is EIFL, which is not in widespread use. In most languages, design by contract ends up being implemented through the use of assertions.
Okay.
And you're asserting both the preconditions and the postconditions to the degree that that's possible. And depending on what you're talking about, it may or may not be possible to fully assert all of the preconditions and postconditions. But yeah, those end up being kind of a defensive programming technique in that they become a way to protect against somebody calling a routine that you wrote and violating the assumptions under which the routine was written. So just use a super mundane example. Let's say that I've got a variable that represents temperature in degrees Celsius, and my allowable range for that is 0 to 100 degrees. I can assert that the input value for that variable is between 0 and 100 degrees. And if someone passes me an input variable that has a value of 1,000 degrees, then the assertion fails. And this is distinct from error checking because I'm not going to, if the assumption that the routine is making is I'm always getting a value between 0 and 100 degrees, I'm not going to do error checking. I'm going to assert that it's between 0 and 100 degrees. And if I get a value of 1,000 degrees, the consequence of the assert is that the program stops executing, it halts, and then the programmer who called it incorrectly has to fix the code.
So are we going to run into a bunch of Y2K issues related to global warming now?
Y2K issues related to global warming. Yeah, maybe if we, I think we're within the error bars on that
100
one.
degrees.
Yeah.
Okay. Well, I think we have time for one more principle today, and that's related to the idea of software delivery efficiencies through the use of automation. The principle is automate repetitive activities. And technical debt requires stakeholders and developers to think at the creative level, non-deterministically sometimes, to address when and how to retire technical debt. Architecture, as we just talked about, is another area where software engineers have to think about the creative level to achieve something that hopefully downstream pays off in a lot of ways. But
Yes.
there are a lot of things that you note in more effective Agile that become more close-ended and deterministic as an idea flows from concept to production. And yesterday, you and I were talking about this in preparation for the podcast today, that, another way that these keys are maybe threaded together is that, and I want people to pay attention because this is not in the book. This is bonus content.
Bonus content.
Bonus content. That's the idea of aesthetic sense. And I love this thought because as an engineer in my career, I always did things that mattered in my design work. But for sure, I did some off-road stuff because some stuff just bugged the crap out of me. I needed to take care of it, right? So automation was clearly born from some poor engineer saying, I'm not doing this manually again, this sucks.
Yeah.
Right?
Yeah.
And so let's get a little bit more serious here. Give me some more sophisticated examples of these repetitive tasks that lend themselves to this idea of automation in software, and in particular with Agile practices, what things are put in play for that kind of thing.
Sure. Yeah, and I'd definitely like to come back on that aesthetic point because I think that is an interesting point. So let's just talk about the basics of the key principle first, which is to automate repetitive tasks. I think the idea here is that computers are good at doing repetitive tasks, and humans are good at doing tasks that require some sort of novel thinking. And so to whatever degree you're having humans in your organization doing repetitive tasks, you could actually replace those humans with a computer that costs $1,000 or $2,000. That's going to be a lot cheaper than having the human do that task over and over again. And beyond that, it's motivating to the human to do new and original
Absolutely.
things, whereas it's often demotivating to do repetitive things. We've talked before about autonomy, mastery, and purpose. And the human, when you think about it from the point of view of mastery, doing something repetitive doesn't give you the opportunity to develop any kind of mastery. Purpose also is at risk in that, because if you feel like your purpose could be replaced by a machine, it's not very satisfying either.
Never happened.
Yeah. And then I think we have the additional consideration. So basically they're just pure staff management reasons to try to automate repetitive tasks. And then as we get into iterative practices, where because we are delivering more often, we are doing some of the activities more often, and that really does call for a higher need to automate those activities that are now getting repeated more often. And so the whole idea of deployment pipeline and DevOps, I think is really probably the main example of this, where we're going to automate. We're
Build structures.
well, like back in the day, we didn't even have automated build process. That was manual. So in most organizations, we're many, many years past the idea of a manual build process. We still see it occasionally, but mostly the build process is automated. Then we get to the point where we're automating the test process, and we can push that all the way through to automating, the approval of the tests and then the actual deployment of the software. And I think this is an issue that companies are struggling with currently as DevOps matures, is just to what degree does it make sense to do that? And where do you insert the human judgment in that loop? And there are some really high-profile examples, like Amazon gets brought up in pretty much every discussion on this topic, where there's a very high degree of automation and software is being deployed every couple of seconds or something like that. And for a lot of companies, if they're developing software for a hardware device, there actually can still be really good benefits to automating, but they're not deploying every few seconds.
Right.
They're way less frequent than that. Even if you just think of the deployment as an internal delivery, not deployment per se. But I would like to return to that aesthetic comment, because I think that does come into play here too. I have a theory that anybody who's really good at their job develops an aesthetic sensibility about their job that's largely invisible to anyone who's A, not also really, really good at that specific job, or B, maybe even that individual person.
Right.
And I think both those levels matter. And so, like when we talk about coding style, for example, there's an aesthetic element to coding style that is discernible to other software developers.
They'll say things like, "I can tell who wrote this code."
Right. And but there's also, I think, a level beyond that really is discernible only to the person who wrote that code. And so I think when we started the discussion in this episode on the topic of technical debt, there are things that really are debt, but there are things that individuals on a team would say are debt that really are not debt. It's just something that violates their aesthetic sense of how things should be. And one reason I think the debt discussion is helpful in that context is when they have to actually come out and say, all right, well, how much more is this going to cost you later than it costs you now? If the answer is, well, it costs the same, it's just bugging me that it's this way now, I'm not going to completely write off the fact that it's bugging them. I mean, that's, that counts to a degree. But if it's only bugging you now and you want to spend an extra 2 weeks to get this release out, and I'm actually coming up against a holiday sales season or some other seasonal deadline, maybe your aesthetic sense can wait for a couple weeks until we get our release done. In architecture, we see pretty similar issue. I think a lot of the projects that we've seen go sideways with these re-architecture projects, we will hear people say we're refactoring our architecture. And, refactoring is a really powerful concept, but sometimes it can be used to support aesthetics more than to support truly higher quality. And there too, I think, there's not any real value add when an organization spends a few months quote, refactoring their architecture, but they don't actually add any additional capability. That's an exercise more in aesthetics than it is in business value. Would you consider
things like maintainability as an aesthetic moving forward? I mean, that's, in some respects, we when we do code reviews here, we'll look at that notion and look at a code base and say, that yes, this is fine, but from a maintainability perspective, you might want to make adjustments to it, right?
No, I would not consider that. And I guess that is a useful point. And I should differentiate between aesthetics that overlap with useful considerations versus aesthetics that exist purely for their own sake. And so if we talk about maintainability, then we're talking about simplicity and understandability. Is understandability only an aesthetic consideration? No, understandability affects
good point.
Whether people can make changes accurately, whether they can fix defects accurately, and it's also an aesthetic consideration. So my comments are really about the point when you're way out on the far end of the bell curve and you're really talking now only about aesthetics.
Polishing the whatever.
Yes.
Your favorite analogy.
And then we get to the automation point, and that can be the same thing too, where if I'm doing a repetitive task every day and it's taking me an hour a day, it's pretty easy to make the argument that I should automate that repetitive task.
You bet.
If I'm doing a task every month and it only takes me 5 minutes every month, it's pretty hard to make the argument from a business point of view that I should invest hours to automate that task. And it might just bug me, and that becomes another aesthetic issue where it's like, I don't have a good sound business justification for investing in automating this, but if it really is just grating on me every time I do it, I think we often see software developers automating that sort of thing anyway. And
Right.
I put myself in that category sometimes as well.
Right. So, in the list of things you mentioned in the book that lend themselves to automation, is testing is one for sure.
Sure.
Right? It's a big one, and a lot of people spend a lot of energy in test automation engineering. I think there's an entire field devoted to that. People spend careers working on those kinds of specialties, which I think is cool. I mean, that notion of user acceptance testing is another one I think that probably lends itself really well to automation techniques, right? What other things can you think about that would be useful there? I mean, builds we talked about, CI/CD kind of stuff, right? That there's a whole tool chain and et cetera that grew up supporting that over the last 10 years or 15 years or so, right?
I think we've mostly talked about the categories, and the rest would get awfully detailed. But
Right.
testing is probably the largest single area that we've focused on for the last 10 to 15 years or so. And I think, as you implied, it applies across almost the entire field of testing.
Right.
To the degree that we're now talking about human random testing as its own category, or heuristic testing as its own category, and it's assumed that everything else can be automated. So if we're talking about stress testing, system testing, compatibility testing, unit testing, even user acceptance testing, all those are lend themselves to being automated.
Sure. And even AI techniques are creeping into a lot of that, right?
I suppose, yeah.
Yeah. It's the big buzz.
AI is in the same category today, I think, that Agile has been for a long time, which is that, if we're going to have a discussion about AI, first we have to define what we mean by AI.
Absolutely.
And then we'll have the discussion about specifics. But without defining specifics, I think we don't even know what we're talking about.
There you go. Well, we'll save that for later. So I think that's good. I think we're going to stop it there. I think we're going to have to leave it for this episode. Thanks again, Steve, for bringing in a lot of insights to these topics.
Thanks for your
I'm
questions.
sure you'll come back to see us again. We know where you live.
Yes, you do.
All right. Be sure to tune in again for another episode of Inspect and Adapt, the Construx podcast. Until then, this has been Mark Griffin as your host. Liz Ostaszewski has been our audio engineer, and Devin Musgrave has been, again today, our producer. Have a great next sprint. If you enjoyed this episode and you have comments or would like to talk with one of our practitioners, reach out via email using comments@construx.com. Again, that's comments@construx.com. We'd love to hear from you.